So if you recall, last time we were looking at these complex and we realized this code is not as good as it should. We'd like to treat objects like complex exactly as if they were values like int or doubles. Objects should be values, and I should be able to write a beautiful expression like C1 plus C2 and have that be the code. So can we actually do that improvement? And the answer is, of course, yes, we can. So let's make that change in the code. So what we're going to do is go back to our header file, which is not student, right? It's complex1.h. And I want to actually not use that add. I want to have something that's a lot cuter than that. So let's see how we're going to do that. Well, the trick is you can actually implement an operator. But you see that the operator plus here has two arguments, right? I have the plus that takes an A and a B. Whereas the add method here is a method on a class, and it takes only one argument. So it's a method of one argument. It's not really a function of two arguments. I really would like to have a function. And that's how we're going to do that. We're going to overload the operator, but really write a function, right? We don't have to be pure and pedantic. Introducing an addition operator has a method of the class. It's a little weird. It's much better to introduce a function. So what I want to do is put a function, but somehow that function should have access to our class, right? To the class we have here. And there is a mechanism to do that. It's to define a function which actually is supposed to work in tandem with our complex class. It's going to be a body of our class complex, and the way to say that is that it's not any kind of function, it's a friend function. Friend basically says what follows is not a method. What follows is a function. Now, the function, I want to use the plus symbol, so it's not going to be a normal function, it's going to be an operator. And it's called the operator plus. And what it has is that it takes two arguments, and we know full well what these arguments are. They will be two complex number, A, exactly like we spec'd it out here, and then a second one, which is const complex reference B. Now, I'm making them reference to constant complex because I know full well that the operator plus is not supposed to modify these guys. He's supposed to actually add them up and produce a result. By the way, the result, I haven't given it yet, but that there is an easy fix. It's before the operator plus, I give the type of the result, and that's going to be a complex, of course. Now, this is a complex by value, the result, right? Because I'm manufacturing a brand new complex number. So that's not a reference. So the reference are used here and here because those are my input. I want to have reference for performance reason, no reason to copy the object, yet the objects are read-only, hence I have const. The result, though, is a value. It's not a reference, it's a value. I'm not modifying either A or B. I'm building something brand new. And how do I implement this? Well, I could put it in line. And of course, the implementation is like, well, why do we torture ourselves? We already have the add method. So why don't we make use of that? We could just say return A.add B, because we already have the implementation after all. Now, once this is done, you probably realize, but who's going to call add then? And my answer is nobody. Who would call add? The only one who calls add is this friend function. So what I'm going to do is take my add, which is quite handy, but I'm going to move it in the private section of the class. Now, the add is a private method of the class, and nobody else sees it. I just have the friend function making use of it. And the friend function can use a private because he's a body of the class. He's a friend function, and therefore he has access to private members as well as public members. So friendship means that this function has all the same privileges in terms of access as if it were a method. It has the same kind of privileges, so it can access private data members as well as private method. So that's straightforward to do in this case. Now, if you're observant, you probably realize, oh, this is not going to work. And why is that? Well, think for a second. I said here that the input of the operator plus are two complex numbers, and they're both references to constant complex. But what is the spec of add? Let's go look up a little bit. And add is a method which, when invoked on an object, will take as input a constant, a reference to a constant complex, then do some calculation and return a complex. But we didn't say anything as to what was the fate of the object on which add is invoked. Is that object going to be modified or not? We look at the code and realize, well, of course no, right? We are looking up the attributes of the object on which we're invoking this. We're looking up its read part and its imaginary part, but the object itself is read-only. Therefore, we should say so, and the way to say so is to add a const to the method to point out, hey, my friend, the object on which add is invoked is constant. When you're going to invoke add will not modify that object. There is no risk of accidentally damaging the receiver as a result of invoking add. And therefore, since friend has a first argument a, which is a complex, in the invocation of the call here, I'm invoking the add method on an object that's not supposed to be modified, but add promises it won't modify it, so everything is okay. We are in a very good shape. This is a correct implementation. So now we did it. We have a beautiful assignment operator, and we used friend functions to actually do that and have a nice implementation. So now that we've done this, we can go back into our test complex and basically say, oh, here, look at that. We're going to beautify that. We don't need to say .add, we can say plus. Now, this starts to look like something completely sensible. This is a much better looking instruction. So does that work? Let's go back in the shell. Let's compile both files. So I need to compile complex 1. It compiles fine. I need to compile test complex. I need to link both. I need to run TC. Everything works exactly as before, except now the code is much more elegant. It's much more readable because I have used an operator to write my expression. Now, you're probably thinking, what can I overload? Well, all the arithmetic operators, plus, minus, times, division, unary, negation, you can even overload exponentiation. You can overload whatever you please. In particular, the bracket operator for accessing an array, you can overload that too. The function call, you can overload that too. The dot to dereference an object, you can overload that too. The comma operator, you can overload that too. So you can overload an awful lot of operators. Now, of course, what happens is that when I give you all that power, you might be tempted to start overloading things left and right and really overload lots of operators. Be careful though, because you have to remember what has been overloaded. And if you use or assign unusual semantics to the overloaded operator that you provide, any users of your library might end up being extremely surprised when they will see what the code is doing. And they might not understand what's happening. So operator overloading is a great thing, but there is a reason why they stripped it when they designed Java. For most people, it's difficult to use. But for a reasonable programmer, it's a great facility that makes it possible to have very beautiful syntax in your code without making things fussy, messy as a result. So I would actually enjoin you to take a look at that. Great, so we've covered everything I wanted to. The next couple of slides, if we look at the slides up here, they really correspond to the code I've discussed. You will see that I've done both addition and multiplication, but that was our original starting point. You have here the implementation of the whole thing, but again, you will receive the source code. That's what we had when we used the test example, and it was quite ugly, but we've already addressed that by doing all the cleanup so that the add or the multiply ends up using operator overloading. So we've done that, and we've used non-member functions to do that, those friends guys, right? And this is really nice. It allows us to write plain old functions that take objects as input and where we're overloading the standard operator. So that's really nice. You see here the implementation of addition and multiplication, and they're both done in the same way. And I have again moved addition and multiplication out into the private part of the complex class, because after all, once these operators are available, who's going to use that? Only the guys implementing this part, right? I still have the print that's a little bit of an eyesore, but thankfully this is quite easy to fix. And that's what our program looks like at this stage. So we'll meet again in the next video, where we'll take a look at the last cleanup we can do here for this part, which is still looking quite a bit ugly because we interleave output operators and calls to print method, and that's not very nice. It would be much better if our object were printable exactly like double, integer, and whatnot using the standard output operator. So let's do that next time.